Here's a slightly more difficult example. This one's tougher because we have to factor one of the denominators before we do this. Okay, if we remember from factoring quadratics, we know that this is a difference of squares problem. So x squared minus 1. Turns out that this is the product of x minus 1 times x plus 1. And you can confirm that by using FOIL. Okay, so we're going to rewrite the equation with our newly factored term here. So I move this out here. So we haven't changed the problem. We've just factored one of the more complicated expressions. Okay, now we got to find our lowest common multiple. Well, if we think of this as A and this is B, our lowest common multiple of A and B in this case is going to be AB. So now we're going to multiply both sides by this whole thing. We have to multiply every term by this whole thing. Okay, so hang on to your hat here. Okay, so now some stuff is going to cancel out. So we're in luck. Okay, this cancels out. All of this cancels out. Oops. Okay, I'm going to go ahead and multiply that out. Okay. And we know it's going to be x squared minus 1 because we just factored that thing. Okay, now we've got to do FOIL. We just got to distribute these. It should be no problem. I'm going to rearrange this a little bit. Going to combine some like terms. Okay, now we have a quadratic. We want to set this thing equal to 0 so we can either factor or use the quadratic equation. So if I bring 3x squared over here, I'm going to end up with x squared. Okay, there's no linear term over here, so okay, I'm going to subtract 9. Okay. Now to make room, I'm going to write up over here. So we need two numbers that multiply to -10 but add to -3. We're going to factor this thing. This is easily factorable. Okay, so two numbers that multiply to -10 but add to -3. And so our best choices are going to be -5 and +2. Okay, so we know that by the zero product rule, x is 5 and -2. Okay, so we take these numbers, we should be able to put them back into our original equation and see that this is true.